Okay, so let's look at this concept of extraneous solutions as they show up in radical equations like this. So this equation here has a radical in it, so it's pretty radical, and uh, it looks pretty simple, but there's some weird stuff going on. You're probably thinking, well, just square both sides, raise both sides to the power 2 to cancel out the square root, and that would make sense. But let's see what's going on a different way. Let's see what happens if we graph y equals the square root of x here. So with a calculator here, if we're trying to solve this equation, the normal way we do that is we're going to graph y equals the square root of x, like so, and then also y equals -5, like so, and graph both of them and see where they intersect. So this part right here is the square root of x part, and here is the y equals -5. And you can see that they never intersect because the result of a square root is always positive. You're only allowed to plug in positive numbers into it because if your value of x is negative, like if you try to plug in x equals -4, then there is no y coordinate there. So that's why there's no points where x is negative. And there's also no points where y is negative because the result of a square root is always positive. So it's never equal to -5. So to put that another way, there is no value of x that makes the square root of x equal to -5, so there's no solution. But what if we didn't know that? What if we just naively went into this and we tried to solve it algebraically? Let's see what that would look like. You'd probably say, well, you want to cancel out a square root, so let's raise both sides to the power 2. That would make sense. So we're going to square the left side, square the right side. That will cancel out and just leave you with x. And then -5 times -5 is, of course, 25. So you'd be looking at this and say, oh, I didn't make any mistakes solving this equation, so it looks like 25 is a solution. But then, of course, when you check it, you know what's going to happen. You're going to get the square root of 25. You want to see if that is equal to -5, and it's not, because the result of a square root is always positive, and you get +5 equals -5, which is not true. So that means that's not actually a solution. So what happens is that when you square both sides, you're taking something that was negative, like this this -5 here, and when you square it, it becomes positive. But then the thing on the left had to be positive, and squaring it just keeps it positive. So you're kind of like, in a sense, losing the information that the left or the right side of this was negative. And you're getting a solution of x equals 25, but it's not a solution of the original thing. So that's kind of my explanation for why this can happen. You could end up with extraneous solutions whenever you square both sides. And this applies to raising both sides to the 4th power or the 6th power. All of those are even numbers, and both of those could make this, get this issue of making a thing that's negative become positive. So the moral of the story here is whenever you raise both sides of an equation to an even power, like the power 2 or 4 or 6, you may end up with extraneous solutions. And this is an example of an extraneous solution. What the word extraneous means is kind of unnecessary or irrelevant or not what we're really looking for. And I think we probably shouldn't even call them solutions because it's not actually a solution of the original thing. This equation, the actual answer to this question is, of course, that it has no solution. That's still the answer here. It's not x equals 25. So x equals 25 is not really a solution at all. It's just like an extra thing that appears like a solution, but isn't really a solution. So that's why throughout this section you're going to have to check your answers. Because most of the time it's not going to be so obvious that an equation has no solution in the beginning. Let's look at another example now. Here's a more complicated example, and give yourself a pat on the back if you challenge yourself to solving it yourself without seeing my solution, but you don't have to. So let's try to solve this equation. First thing we're going to do is get the radical by itself. So we're going to subtract 4 from both sides, and that gives you the square root of x plus 2 by itself equals x minus 4. And now we're going to square both sides, which cancels out the square root on the left side, so you just get x plus 2. On the right side, remember that this is not the same thing as x squared minus 4 squared. You can't just distribute exponents like that. What it really means is x minus 4 times x minus 4, and you've got to FOIL that out, which is going to become x squared minus 8x plus 16. So now let's get 0 on one side to try to solve this quadratic equation. So that gives you 0 equals x squared minus 9x plus 14. And from there, you could solve this by factoring, or you could use a quadratic formula, or you could try completing the square. Or instead, let's just try solving it with a calculator, because that's an important thing to know how to do. So we're going to graph x squared minus 9x plus 14. Oops, I forgot the x in there, so I'll do second insert to put the x there. And then also y equals 0, so we can see where these intersect. And there's the graph. So we're going to do second calc to go down to number 5 to get the intersection. First curve is that one, second curve is that one. Just hit enter twice for that. Then move the guess close to where you think the solution is, and you get x equals 2. So it's one solution here is x equals 2. Then the other one, we're going to do second calc again. Go down to number 5, intersect. First curve, just hit enter. Second curve, hit enter. Then move the cursor closer to the other point when it asks for the guess. And the intersection is at x equals 7, y equals 0. So those are two solutions of this equation. Let's check that they are actually solutions of the original equation on the side here. So the x equals 2 is going to turn into the square root of 2 plus 2, and then that plus 4 equals 2. We want to see if that works, and that's going to give you the square root of 4 plus 4. Is that equal to 2? You know what? It's not, because this gives you 2 plus 4, and that is not equal to 2. So this is an example of an extraneous solution. X equals 2 is a solution of this equation, but it's not a solution of the original equation. It was introduced when we squared both sides. So that is an example of a non-solution. So let's try x equals 7. That's going to give us the square root of 7 plus 2 plus 4. Is that equal to 7? So that's going to give you the square root of 9 plus 4. The square root of 9 is 3. So yeah, this one works. That is a solution. This one is not. So let's just put a box around that one. So yeah, this is another example of an extraneous solution.